Hi folks, welcome back to Math with Captain Rod. Making this video here to help you out with your section 6.5 homework. We're going to look at the following four problems, starting with number 10 here. Write as one logarithm, or write as a single logarithm, this expression. Log base 3 of 2 plus log base 3 of a plus log base 3 of 11 plus log base 3 of b. So we're going to use the property that the sum of the log of a product is the sum of the logs. So this is going to equal log base 3 of the product of these things, 2 times a times 11 times b, and I'm just going to write the 2 times 11, that's 22, and then a times b, and that's done. That's really all there is to that one. All right, number 16, the directions basically say to expand this into a bunch of logarithms. So we're going to use the property that the log of a quotient is the difference of the logs. So this can be written natural log of a to the minus 2 minus natural log of b to the minus 4 minus natural log of c to the 5th. Minus because this thing's in the bottom. Again, minus because this thing's in the bottom. If you wanted to rewrite this and, for example, put these 4 b's upstairs and these 2 downstairs, like write this natural log b to the 4th over a squared c to the 5th and then work it, it's perfectly fine. This thing is expanded. However, I'm going to go ahead and do one more step here and take these powers and write them out front. We can write this one as minus 2 natural log a. This one we can write as minus 4 natural log b, and there's another minus sign in front of it, changing that to a plus. And this one we can write as minus 5 times natural log c, and that's expanded and looks as aesthetically pleasing, I think, as possible. All right, 26. The directions are basically to change this thing to base 10. So here's how I do this. We say, all right, this is some number. Write it in an exponential form. 14 to this number equals 55.875. Right, now what we do is take the log of both sides. So the next line is going to read log of 14 to the n equals log of 55.875. You can choose any base you want. However, this says to convert to base 10. That's why I chose base 10. We use this beautiful property of logarithms now that this can be written n times log of 17 equals log of 55.875. I'm not sure why they didn't just call that 56, but and now it's just a matter of dividing both sides by log 17. I'm going to cheat and use my computer system here to divide. And we're done. So n, which is our original quantity, is equal to log 55.875 over log 17. All right, number 36. It basically says to evaluate this expression without using with using a calculator. But our calculator doesn't read base 4. Calculators will only have base 10 and base e. At least I've never seen a calculator with other bases. So this is some number that we're looking for. Let's go ahead and write it in exponential form. 4 to the n equals this thing. So 4 to the n equals 15 halves. Now, let's go ahead and change this to base 10. So we'll take the log of both sides. Log of 4 to the n equals log of 15 halves. Tired of writing 15 halves, I'll probably write that as 7.5 next time around. Right? This now, n, or this term can be written n times log of 4 equals log of, if you don't mind, I'm just going to write that 7.5. That's what 15 halves would be. So n is equal to log of 7.5 over log 4. I'm going to go ahead and, let's see, I got a calculator handy here. I'm going to find the log button on it. Huh. Well, this is pretty odd here. The calculator that I have does not have a log button. I'm going to look over it one more time. It's a very small, cheap scientific calculator. Okay, so, which doesn't have a log button. So I'm going to leave this as an exercise to the reader here. Just take your calculator, hit just the way you see it, log 7.5, divide by log 4 equals. Fill in a value, you'll be done. I hope this video helps demonstrate how to work these problems. Have a great day.